Hi, my name is Sharun Razia and this is lecture 1 for BITS 2323 Wide Area Network. So our topic today is connecting to the WAN. So first I will introduce the objective of or learning outcome of this lecture, and we'll see some of the WAN technologies overview, and later we will select and understand different kind of WAN technology. So this is the objective for today's class. Let us look first at the WAN technologies overview. So what is the purpose of WAN? Why we choose a WAN? So in the previous semester, you have learned about local area network. So if you look into the diagram here, you can see that if the network is within certain building or within certain organization, so basically that is what we refer to local area network. But when the network operates beyond the geographical scope of the local area network, beyond your organization, which is like, for example, if you would like to send a packet to a remote site, so basically now the network operates using wide area network technologies. So wide area network is used to interconnect the enterprise LAN to the remote LANs or another LANs in branch sites and telecommuter sites. But it's not necessarily connecting between one organization with its branch. Is also like if you would like to connect with different organization. So the technologies that is used to interconnect this operation is called as WAN. So basically, in local area network, the owner of the network is the organization itself. But in wide area network, the ownership of the network is owned by the service provider. So whenever an organization would like to connect to the remote sites or to another location or another organization, so this organization must pay a fee to use the provider services to connect sites because the WAN technologies is owned by the service provider. So are WAN necessary? Yes, it is. Because businesses require communication among geographically separated sites. Like for example, regional or branch officers must be able to communicate and share data. Organization must share information with other customer organization. And for the telecommuters, which is the mobile workers, they must access information that resides on their own office. But sometimes WAN is not only necessary for business requirement, so home users also require WAN. So home computer users must send and receive data across increasingly large distances. For example, you as a banking customers will communicate over the internet for the bank servers, right? Or you as a student at home will do some research by accessing libraries and publication located in other part of the country or in other university and in other parts of the world. So let us look at the WAN operation. So this is where wide area network sits in the OSI model. So in the 7 layer of the OSI model, so basically one access and on contrary to what people believes, because what we see is we are sending a packet to different network. So some students must thought that okay, once operate on network layer, but on contrary from these beliefs, one access standards typically describe both physical layer and data link requirement. So basically, one protocol um, sits on the data link layer. So this is the some of the one services or one wide area network protocol, which is HDLC, PPP, frame relay, Ethernet ones, MPLS, VSAT, and also broadband. I mean, they are sitting on the layer 2. So not only LAN sits on layer 2, WAN also sits on layer 2. So this might be a surprise to some of you because you know that when the connection or the network involves router, so basically the standards or the protocol will be on the network layer. But on contrary from what you believe, so one service sits on a data link layer. So, WAN access standards are defined and managed by a number of recognized authorities, including the International Organization for Standardization (ISO) or TIA and also EIA. So, basically, standards describe how to provide the electrical, mechanical, and also operational connection on the physical layers. So this is the diagram shows a mixture or integration of one device. So basically here you can see that there is a different devices involved in one. So if we look at the one that I highlighted here, so it involves one switch, the core routers, and different type of technologies, right? So basically here, for one to operate, usually it involves two type of switching. Okay, so two main method uh, um, of performing a connection over the one are through switching. So there are two main type of switching, which is circuit switching and also packet switching. So circuit switching is the most common type. The most common type of circuit switching is PSTN and the integrated service digital network or ISDN. So first of all, I would like to explain what it means by circuit switching. So circuit switching is specifically designed for voice. Okay, so if you look in the diagram here, you can see that the end device for each user A and B is actually a telephone. Alright, so basically here insert what happens in circuit switching, because it is designed specifically for voice communication, is not ideal for data transmission. So in circuit switching, what we have here, okay, can you look at the connection when A is dialing B, okay. So what happened here is it will create a it will create a dedicated channel between A and B before they can speak to one another. So what we have here, if you see the connection in red, that signifies the dedicated channel that is created uh, when A is trying to establish the communication with user B. So basically here, that's why circuit switching is most often seen in telephone system that require a dedicated path. So the circuit switching, which is set up at the physical layer, will send the entire message through the dedicated channel. So because of this, it is not suitable for normal data transmission, right? Because usually data is sent and received in streams, which means that the line would remain idle in between transmission spurts. So that's the idea. So now let us compare with the packet switching. So in packet switching, it does not require dedicated channel. So what happened here is, like for example, you have server 1 and server 2. So remember that this is packet switching is usually used for data transmission. So what happened here is packet switching does not require a dedicated channel. So whenever server 1 in this diagram, whenever server 1 would like to send data to server 2, So basically, the packet-based network will break down the message into a smaller packet. So, and then it will try to look at the most efficient route or the best path to the destination. So, if like for example, if we look here, so say for example, you have one big chunk of um, message. So this particular message will be break down into like for example packet 1, 2 and 3. So it's not necessary that this packet will be sent over the same route. So packet 1, okay, from server 1 to server 2, so maybe they will choose um, if we look here, it seems like there's only one way to do it. But say for example, if like for example, I'll create another link here. Okay, so one might occupy, I mean, use this path. Packet 2 may use this path, may go through to this path, and packet 3 may go through to this path. Okay, so they can definitely use different route according to the bandwidth, according to the congestion on each of the route. So there's a bit of decision need to be made to send the packet to the destination. So once all of the data packets reach the correct destination, so this packet will be extracted and reassembled back to create the sender's original message. So the difference in packet switching, because we could see here that in circuit switching you have a dedicated channel, so you definitely have a dedicated bandwidth from point A to point B. So hence the reason why packet switching is most often used for data and voice application that are not time sensitive. Okay, so if it's time sensitive, you need a dedicated channel, so you may opt for the circuit switching. So some of the technologies used for circuit switching is PSTN, also SDN. So the differences here is PSTN is only provides a single connection, which means that both device cannot occupy the line at the same time. But on contrary, the ISDN, both of the device can send data simultaneously at the same time.